right, we're taking a look at day 2 here, which is piecewise functions. So number one, the piecewise functions is a one function that is actually made up of two or more graphs that are put together. And so what happens is we end up with something that is kind of referred to as a restricted domain. All right, so we're going to take a look at an example here for the first one. So when you're looking at this, you can notice here that this has the x values, and each of these values here, okay, is describing how you're going to graph based on the x values. So if you have any x values you can see in the graph that are -1 or less, then we're going to use this graph right here, okay, as our graph for this question. So this is the graph whenever x is less than or equal to -1. And you can see on the next one that if we're in between -1 and 1, we're going to do a graph of 1. And then you can see on the last one, whenever we have a number that's greater than or equal to 1, we're going to use x squared. So we're going to talk today about how to graph a function like this, and then also how to interpret points, x values, find the y values based on certain x values. Okay, so number one, their pieces may be all linear. They could be a combination of forms like a linear or a quadratic or a square root or a cubic. And they may also contain breaks or like a jump. We'll talk about a jump later. All right, but a continuous function, in order to be continuous, okay, there's no breaks, no holes, or no in the graph. That also means that if you put your pencil down or pen and you could draw the line in one motion without picking your pen up, then it's also continuous. If you have to pick your pencil up and move it to continue to graph, then this is not continuous. And this is actually called a jump because the function jumps from one point to the next. And you'll notice that in order to be a function, you're going to have one open circle and one closed circle, so that there's not a vertical line test you can draw that hit the graph more than once at those points. And we'll also talk about that as we go along here. All right, so let's go through and take a look at the first question. So notice on this graph we have the blue graph, the red, and the green. So if you look at how we're graphing, when x is less than or equal to -1, you can see that we're essentially clipping this graph. When it's between -1 and 1, we're taking the middle graph, which is a horizontal line crossing through 1, or y equals 1. And then when it's greater than 1, we're taking y equals x squared, and we're taking all these snippets and we're sliding them together to form this function, this piecewise function here. So let's talk about how to graph a piecewise function. So number one, your calculator, you can use your calculator to graph the piecewise function here, okay? So I'm going to take out my TI Inspire. All right, and we're going to open up a graphing page, and then we're going to type in the graph. Now, because it's a piecewise function, we have to remember that there's 4 parts to this, and there's this little left side of the brace. So what we need to do is we're going to press the symbols button, which is right next to the number 9. And then you can see right here we have a brace with 4 openings, 4 unknowns. Here there's only 2, and there we need 2 more. So we're not going to pick either of these 2. We're either going to pick these, this symbol or the one next to it, depending on if we have 3 or 2 graphs to use. And then all we're going to do is type in exactly what we see here. So we're going to do x plus 5. We're going to arrow to the right to fill in there. And then we're going to say x is less than. Remember, we're going to do control equals to get the less than symbol up. And we're at x is less than -2. Or we can arrow down. And the second graph is the -2x minus 1. Okay? And remember, to use the negative symbol, you actually want to use the button next to the equal sign here. And this is when x is greater than or equal to 2. So control equals to bring that back up. Greater than or equal to, and it's -2, sorry, I said 2. And then when you hit enter, notice that it's going to graph the function for you. And if you bring up the table, you'll be able to get the values of y based on our x values. So we can use this table to help answer these questions. We'll get there in a second. Now, if you don't have a calculator and you want to graph these, what you're going to do is you're going to take each function. So let's take a look at the first function. We're going to say x first, And then instead of writing like the y value is actually what we get when we plug into x plus 5. So because we're starting at -2, right, that's the number and the inequality, I'm actually going to put that number first. And I have to remember that since there's no equal sign to this inequality, that this is actually supposed to be an open circle when I graph it. So if I plug -2 in for x, we get -2 plus 5, which is 3. And then the next number that we would want to pick is less than -2, so we would want to pick -3. And maybe we'll choose -4. And as you plug in -3 plus 5, you'll notice we get 2, and -4 plus 5 becomes 1. So if we graph these points, we'll see what happens, what the trend is in the graph. So -2, 3. Oh, that's -1, 3. -2, 3, and remember, it's an open circle, not a closed. So we're going to open circle here. -3, 2, and -4, 1. And you can see that these points are starting to form a line. And so we can draw in the line now, and that is the first part of our piecewise function. So now we're going to do a table for the second function. So we'll go off to the side again. We'll pick x, okay? And then we're going to do y equals, or f of x equals, -2x minus 1. So we have to plug in to get the answer. So we're going to start once again with the number from the inequality, which is -2. And if we plug in, we're going to get -2 times -2, so that's +4, and then -1 is 3. Okay, now we want to pick a number that's greater than -2, so we'll try -1. -2 times -1 is 2, -1 is 1, and if we put in 0, we're going to get -2 times 0, which is 0, -1, so this becomes -1. Now, you can notice that on our graph, see how the functions actually touch at that point? So this point, -2, 3, because there's an equal sign here, is going to be a closed circle. And so it just happens that the second function closes the open circle here. And now we can graph -2, 3, -1, 1, and 1, 0, -1. And we can see that this graph forms another line that kind of has a slope of -2 down 2 over 1. Okay? And so when we do this, we're going to get this graph. And that is our piecewise function. That's it. So is it a function? Remember, if you create a vertical line, does it pass the vertical line test? So if I were to try to move this line around on my graph, is there any point at which it touches both equations, right, the line more than once? And you may think to yourself, well, right here it kind of does, but remember that before we graphed the blue line, right, that the red circle was actually an open circle, right? Okay? That the red circle was open. So there's only one point here, and that's the blue line. So it actually doesn't overlap. There doesn't touch more than once. So it is a function, okay? And now, how do we evaluate these numbers? Well, if we have our calculator, right, and we want to evaluate f of 3, we can just go to 3 and we can write down -7. But how do we get it from the equations? Now, 3, if we try to plug it in for x, remember function notation means it's supposed to be f of x equals. So here we know that x is 3. So are we going to plug into the first inequality where we're less than -2, or the second equality where we're greater than or equal to -2? That's right, the second, because it's greater than -2. So we want to plug -3 in here, and we get -2 times, oh, it shouldn't be -3, it should be +3, times 3, so that's -6, and then -1 more would give us -7. So that's why f of 3 is -7. Now, if we plug -4 in, we're not going to plug it into this graph, okay, because -4 is less than -2. So we would use this function, okay? So we're going to say instead of x plus 5, we're going to take the x and we're going to replace it with the number inside the parentheses, which is -4. And -4 plus 5 is 1. And you can notice that on our calculator, when we go to -1, the y value is 1. Okay? And the same thing with -2. If we plug -2 in, now -2, it's not the top one because it's not equal. We have to use the bottom equation. So -2 times -2 minus 1 is 4 minus 1, which is equal to 3. And you can see when we're at -2, the y value is 3. Okay? That's how we're going to graph piecewise functions. All right, we're going to skip number 2. Let's head down to number 3. Let's do one that's a little bit tougher. Okay? So, we're going to do this graph. Okay? We'll talk about how to write these inequalities, and then I'm going to have you try these ones on your own. Okay? Tonight, we'll go through how to kind of do this on a couple of these, and then I want you to try to answer this question right here. All right, so number 2. So once again, we're going to look at our functions. We want to graph it first, so we're going to create a table for the first graph. Because the inequality is at 1, we're going to make a t-chart, x, and then y equals 2x plus 1, and we're going to start at 1. And because we're greater, we're now going to use the points 2 and 3. So we're going to do 2 times 1 plus 1, which is 3. 2 times 2, which is 4, plus 1 is 5. And 2 times 3, which is 6, plus 1 gives us 7. So, because it's a equal to, we're going to use a closed circle for this. And we're going to do 1, 3, closed circle, 2, 5, closed circle, and 3, 7, closed circle. And now we can just trace the rest of the points with our line. And there we go. Second graph starts at 1. So once again, the inequality is at 1. So we're going to do y equals, and we're doing x over 2 minus 3. And the first number is going to be 1 because that's the inequality. Remember, this is an open circle now. And if we plug 1 in, we're going to get 1 half minus 3. Okay? So 1 half is 0.5. Minus 3 is negative 2.5. So at 1, and now we're dropping down to negative 2.5. Remember, we can't do a closed circle because that fails the vertical line test. So this one's going to have to be open so it stays a function. Okay. Now, what's less than 1? The next number would be 0. So 0 over 2 is 0. Minus 3 is just negative 3. So 0, negative 3, we have a closed dot. And then if we try negative 1, we're going to get negative 1 half, negative 0.5 minus 3. And that equals negative 3.5. And so that's here. And so the second graph is going to look like this. And that's our graph. We're done. Okay? So how do we evaluate? Remember, the number inside is what we're plugging in for x. We have to choose our inequality. So if we use negative 2, that's less than 1. So we're going to do negative 2 divided by 2, which is negative 1, minus 3, and that gives us negative 4. Okay, if we're going to plug in 6, 6 is greater than 1, so that means we're going to get 2 times 6, which is 12, plus 1, so that's 13. All right, and then if we want to plug in 1, we're not going to use the bottom one because it's not equal to, we're going to use the top. So 2 times 1 plus 1, and that's 3. And you can see, we're at 1, we're at 3, right? When we're at 6, which is way over here, we're off the graph, so it's going to be up here at 13. And when we're at negative 2, you can see that the graph is going, should be going through right there at negative 4. Okay? Good work so far. All right, let's try and take a look at number 5. So write equations for the piecewise function shown on the graph below. Now these are all lines, so what I'm going to need to know is what is, if I want to y equals mx plus b, that's what I'm going to look for. So I need to know what's the slope and what's the y-intercept, and then I need to know for the domain, what are the x values used, okay? X values used. So we're going to start off by doing our f of x, and then we're going to do our little brace here. Oh, I forgot. We should have an equal sign there. Then the brace. Okay, so the first function is this. Now, if we continue the lineup, notice that the slope is going up 2 and over 1. So if we keep doing up 2 over 1, up 2 over 1, oh, it's not up 2 over 1, is it? You can see that doesn't actually work. It's actually going to go up 3 and over, is it 2? Nope, that doesn't work either. That means if we just take a look at this point, that would be the next point. So it's actually got to go up 5 and over 3. So the slope is 5/3. If we continue that point, 1, 2, 3, 4, 5, and over 3, here's where we're going to hit the y-axis. which is 1, 2, 3, 4, 5, 6. So the y-intercept is 6, and the slope is 5 over 3. So our line is 5/3 x plus 6. Okay, we don't write y equals because that's this part. And then what x values are we using? We're using all the x values that are below -2, but we don't include -2. So we're going to put a comma, and we're going to say x is less than -2. Okay, second function is a straight line. This is horizontal, so this is just a y equals graph. It's got a slope of 0, and it crosses through the x-axis at 4. So we're just going to write down 4. That's it. Okay, and this goes from -2, 2 and 2, and it includes -2 but not 2. So it should be -2 is less than or equal to x, which is less than 2. And the last function is what you can see right here, and this has a slope of going down 2 and right 1, so -2 over 1. And if we continue that trend up, you can see we're going to hit the graph at the same point here, okay, at 6. So once again, this is 2x plus 6, and our x values start at 1, 2, 3, and go forever to the right, and it includes 3. So that's x is greater than or equal to 3. Now, in my expertise and with having seen so many Regents exams, they rarely will ever ask you to graph or write. They might ask you to graph, but they won't ask you to write the function. So I wouldn't really worry about this. It's usually about what values and evaluating the values. So wouldn't worry about having to write the functions. All right, let's take a look at number 6.